Hi everyone, I'm Pat Prokop in the Heavenly Backyard Garden with Heavenly Backyard Astronomy. Now, the garden's at its peak, so most of the work is done out here with the garden. So now I can look up in the sky with the telescope. I have a little bit more time for my astrophotography activities. And what I have been working on recently was looking at some of the early morning nebulae. Particularly M16. I was looking at M20 as well, M16. Also, you know, we're still at the tail end of the galaxy season, so I was also looking at the galaxy M101, Messier 101, or the pinhead, or the pinwheel galaxy. Now, I wanted to use my monochrome camera, and doing that, I wanted to use the narrowband filters. But I still wanted to get a good color image. So I was thinking, I know that's dangerous, but I was thinking as I was walking through the garden the other day, can I emulate a color image using the narrowband filters? Well, of course, the answer is yes, but how do I do it? And what combination of filters do I do? Of course, you can do a red, green, blue filter, but that's broadband. I wanted the narrowband for a higher sensitivity. And to cut down on the light pollution. So what I did is I used a hydrogen alpha 3 for my red, and for the blue I used the oxygen 3, which is a 4 nanometer narrowband filter. Well, there's the red and the blue. What about the green? Well, I was doing some studies on the colors of the different filters, and the hydrogen alpha is very sensitive into the red end of the light, and the oxygen 3 is sensitive into the green to blue end of the light. But what about the green color? Well, most of the green colors up in the heavenly skies are basically white to look. They look like white. So I figured, well, let's try just a luminance IR cut filter for the green, for the RGB. And well, let's take a look, see what I did.
All right, let's talk about the filters themselves and what kind of light they are actually allowing to pass through. Here you have different wavelengths of light and so forth. You have the red to the infrared way over here to the right, and then going into mainly the visible white light here in the middle. That's what the UV IR cut usually shows. Allows basically everything from here all the way over to here. Now this over here is in the darker red. That's the sulfur 2 light images that you get. This is the hydrogen alpha. A lot of the light coming in from the nebulae is from the hydrogen alpha spectrum right in this area here. And then over here is the O3, and you can see it's the upper end of the green into the lower end of the blue. And I'm trying to get, actually I have it's on the way, a hydrogen beta filter, which is on the upper end of the blue. And then after that it goes into the ultraviolet. You would have to have a mercury filter here to pick up this light over here, but I can't get that. But anyway, here you have the hydrogen beta. And this is going to be interesting to see what this is going to show up. And helping with the light pollution. Now, most of the light pollution is in this ballpark right here, and you try to filter that out. If you have dark skies and out in the country, yeah, this light doesn't matter because it's not around. This is most of it is a lot of the artificial light is in this realm right here. Also, the hydrogen alpha gives you some good red light, so you know that's why we like to use hydrogen alpha. Sulfur 2, and you know it's very on the very end right there. But if you want to, you know, kind of like to get a red, green, blue image, you want hydrogen alpha, and for the red, and the oxygen 3 for the blue. For the green, you want this area right here because that's where all the green light is located. But also that's where the light pollution is located as well.
Now the telescope that I used was the Orion Eon triplet. It's a 130 millimeter refractor triplet telescope, and it's sitting on the Skywatcher EQ6R Pro mount. And with that, I'm controlling it with this mini computer here, and on that mini computer, it's a Windows 10 system, I have NINA. I just love NINA, Nighttime Imaging in Astronomy. And this is becoming an extremely powerful software gathering tool. And the computer itself is operated through my system upstairs via a remote connection. So I have a big desktop computer, and I connect to it from the upstairs to downstairs via remote computer access. So I have complete control of the telescope. Now the camera that I am using is the ASI 1600 mm Pro. And I cooled the sensor down to -10 degrees Celsius. That's my operating temperatures and operating conditions for the system here. And I have a filter wheel using 1 1/4 inch filters.
So let's start off. First of all, where is the Pinwheel Galaxy M101? And let's put on the constellations and see what we have here. It's over here in around Hercules, Arcturus, Bootes right here, Boötes. You have Ursa Major. There's the tail of the Big Dipper right there. So it's right between the two. Now you got the little expression: follow the arc of the Big Dipper. Follow the arc to Arcturus, right there. So it's at the end of the Big Dipper, not too far away from M51. Anyway, there's the Pinwheel Galaxy, and I think I can zoom in here and take a look at it. There you see. That's where it is. All right, let's zoom out. And let's go out and see where M16 is and type in the search over here. Let's go with M16. And let's go to it. And you can see it's way over here in the morning sky. So we have to get into the morning time. And F5, where are you? There you go. And see, at midnight, it's just barely above the horizon, but I got a big tree I have to have it get past. So I usually don't see it until about 2 o'clock in the morning it starts showing up. It's right here in a portion of the Sagittarius arm of the Milky Way galaxy. Anyway, you have a lot of nebulosity out in this area right in here. But anyway, zooming in on this one. Oops. Oh, I forgot to turn off the time. Okay, there we go. Zooming in on this one. There you can see it right there. All right, so that's where they're located right now. And yeah, as I mentioned, you have a lot of other constellations out in this area. Constellations. Also, as I mentioned, you have a lot of different nebulosity and nebulae out in this region. So this is just starting to come up, and throughout the late spring and most of summer, you'll have these targets to play with your telescopes and astrophotography. So have at it. All right, so one of the first things I want to do, let's take a look at the images right now. This is the hydrogen alpha 3, and this is the hydrogen alpha 7. You can see they're about the same. I think 3 is a little bit cleaner, a little bit more narrow. Anyway, we have that. And then this is the, right here is oxygen 3, and this is the luminance right here. Also, I did an S2, a couple of minutes of S2. This is only 15 minutes worth. But anyway, that's for examples. So let's close these up, and let's align all these stars together, all these images to one image. And we're going to take the hydrogen alpha 3 as the reference. So let's go into that. And I'm going to open up the star alignment right over here. And this is the star alignment. And I'm going to take the sample hydrogen alpha 3 as my reference image and say OK, and then I'm going to clear this out and then add the views. Let's add the rest: hydrogen 7, oxygen 3, luminance, and sulfur 2. All right, just do that, and let's, I never know which one to hit. If it's wrong, it'll give me an error message. So let's, I guess that's the right one. All right. Doing its thing, aligning the stars. And these are going to come open with the new frame open with the word registered on them, so you know which one is which. Here we go. All right, now we can take that off, minimize it, and there. These are the new registered images right here. I got the sulfur 2, the luminance, and the hydrogen 7. Where is my oxygen 3? Did I do oxygen 3? I didn't do oxygen 3, did I? Let's do that again. Star alignment. Here. No, I didn't do it, did I? Okay, let's just clear the list. Add views. Oxygen 3. Or there it is. All right. And hit go. It's doing its thing. And now my stars are aligned. All right. All right. So let's next go to everything's set. So let's just try channel combinations first of all. And right here, let's do for the red. Let's take the H3. Okay. And okay. And then for the green, I'm going to take the luminance just for funsies. Okay. And then for the blue, it's going to be oxygen 3. I need to get the registered one, so hang on. Oxygen 3. Okay. And the luminance will be luminance registered, not luminance. Luminance registered. Okay. And hit apply. And there we have the first image right there. And look, you know, it's heavy in the green, which is expected. It's biased green. It's a so let's just go with the SCNR. Extract that green out of it. Let's just see what happens here. And we're getting a better image already. So already I got something to work with right here. It's kind of a bit on the purple side in there. I can take some of that out just by inverting the image. I'll go here, image, invert, and now the purple is this green area here. So let's see what happens. Let's take half of that out. Right there. Okay, and see what happens. All right, go image, invert. Where is it? There. Yeah, so that's already beginning to look better. Oops. Something to work with already right in here. So I have that. Let's try the let's just call this the rename this to the let's see. I'm going to call this HLO. All right. Okay. Now let's try something different here. Let's just minimize this and save it for future laughs and giggles. And let's close these guys up. And what I wanted to do next. Oh yes, let's go back to the channel combination. Let's take, instead of the luminance, let's do the old-fashioned way, the sulfur 2. Yeah, I know. Okay, and let's see what happens here. There's your sulfur 2. Let's get rid of that green. Right there. And let's get rid of that purple. Image, invert, right there. Yeah, you see all that green there? That's purple. Let's take half of that away. And let's delete it. Okay, took some of it off, which we wanted. Put that back to normal. And let's invert the image back. Yeah, it's still purple, but there you can see. That's a start right there. Well, let's try something new. I'm going to delete that. Let's try something new. Let's let's take, we're going to just minimize this one. I don't want that. Let's take the S, no, I don't want that one either. Let's take the luminance registered with the oxygen registered. Okay, go oxygen 3. Where's oxygen? Right here. All right, these two. Let's combine these two together. So I go to pixel math here, and here's pixel math, and I'm going to call that should be 0.5. See my 0.5. I'm going to call this oops. There we go. So this is the image right here, and let's rename that identifier. Let's call that lum plus O3. Okay. Oh, doesn't like that plus sign there. Let's just do an underscore. Okay. All right. So let's try that for the channel combination. So instead of for the green, let's use this new one. Let's go with lum O3. Let's just see what happens here. Oh yeah, look at that. Let's take out that green. And now we got something going here, guys. So with this, I can work with this. That's almost equivalent to the well, it's actually better than the red channel. Now if I do or the one-shot color camera, but I can work with this. That's nice. That's nice. And that's just using the hydrogen, the luminance, and the oxygen 3 all together. Now I can also go, let's do the oxygen 3 and oxygen HOO. That's usually pretty much like what you see with a color camera. Well, let's see what that looks like here. See? So I'm heavy. I'm heavy in all the center light here. Okay, but that looks pretty good too. But I don't like it. I'm going to quit that. Again, this is something to work with right here. And let's take a look at some of the other products that I did work with. And let's open those up right now. All right, so let's look at some of these different final products from these color combinations that I finished up in Photoshop. Now this one right here, this is the original. I don't want to do that. This is the original one-shot color camera view that I took of the Eagle Nebula there. You can see it's mostly red with all the, all the hydrogen out there. And it looks pretty good at that. So one-shot color camera, not too bad at all right there. Anyway, this here was a similarity of that. But this was taken with the one-shot, the monochrome camera, and this is the hydrogen, a combination of hydrogen and oxygen together, and then oxygen. So this was an HOO, kind of modified HOO picture right here, and it's very similar, as you can see. Once again, with the monochrome camera, you do get some sharper stars. When you look at this, I think the stars are a little bit sharper with the monochrome camera right here. Okay, let's back this up. Why are you going over there? Go over here. All right, and that's because I hit that button there. All right, this one here is the hydrogen, oxygen, and then oxygen. Again, the same color that I used, but I used different shades. I shaded them a little bit differently in their black and white versions and came up with this image right here. And as you can see, it's a rather nice looking image. Actually, it looks pretty nice right there. So yeah, that one came out really nice. Again, this is the hydrogen and oxygen mixed together, blended together, and then the O3 as the blue, red, green, blue. And again, just by playing with the shades of gray in the before you combine the channels, makes a difference right then and there. All right, let's close that up. And what's this one right over here? This one's the next one here. This one is one of the finals, but I got too much blue in this one right here. But the nebula looks pretty good. The nebula looks pretty good. All right. I'm going to erase that because I wasn't supposed to show that one. Whoa, what's this? Oh, this is the one where I used the luminance. Now, the luminance, the stars were too bloated in there. I used too big of a stars, and that's upside down. Let's invert this image just for, not invert, I want geometry. I want to go rotate 180 degrees. Okay. As there you can see, it looks pretty good, but those stars are bloated, as you can see from the luminance. So I shot the luminance too long. I need a shorter luminance exposure time, or lower the gain on both, or both. So that's that right there. All right, let's take another look. This was just the nebulosity alone, which is kind of neat when you look at it. And this was with the HO and the O. Okay. And I think this is the one I wanted to show. Yeah, this one right here was one of my final products. I took a star mask, and when I took out the nebulosity, it created a star mask through StarNet. And I changed those blue stars that were all over in here into white, and I just overlaid them on top of the blue stars to make them more look white, because I wanted this blue in here. But you can see I used the luminance as my blue, and I still had these halos around the stars that were bloated. I didn't quite match them all out. Again, that's my fault. I used too much time or gain or length of time on the luminance filter. So live and learn, I suppose. So that's that right there. And yeah, that's what I got so far. Now, I also did this with a Galaxy. I tried it with the Galaxy. Let's take a look. I use M101. As you can see, it's not very bright at all. With the hydrogen alpha right there. And let's take a look at the O3. Not much difference at all. You can see the Galaxy in there, but some of the brighter blue stars on the edges, which makes sense. And then you have the luminance filter here. Well, that looks more like a Galaxy there. Just getting all that white light, or actually the center of the green area, showing all this the light from the stars. And if you combine these into the HLO, which I did, this is the final product here, and not too shabby. It looks pretty good, using the narrowband filters, except for the luminance, of course. Luminance, I use the UV IR cut filter for luminance. But there you have it. And fun with filters, I suppose you can say. That's what we're having right over here. Fun with filters. One. Also, I'd like to take this opportunity to thank all my subscribers to my YouTube page. Here it is, Pat Prokop's Heavenly Backyard: Astronomy, Gardening, and Weather. I do a lot of astronomy and gardening, a little bit of weather, particularly when the tropics get active. That will be threatening our area here in southeastern Georgia and southern South Carolina, or other major areas, major storms. Anyway, a lot of astronomy and gardening. And thank you for all my subscribers already. I'm up to nearly 4,000 subscribers. I'm on my way up. I would like to get 5,000 soon. Anyway, you can also join my page if you would like, and to help me along. I have a couple subscribers already, Willis Sutherland and Mark Green. Thank you very, very much for your support, and you can see all my different videos are associated here on my page. And I have some shorts, been dwelling into those areas of shorts, which I don't know, I guess they're okay, but I prefer the videos themselves. I have more fun making the videos. But yeah, if you like this kind of video and this product, feel free to subscribe to my channel. And I would appreciate it very much. And thank you.
So, using narrowband filters, you can come up with different color schemes using the same filters. I mean, I came up with a red image, which looked very similar to the one-shot color camera view that I shot back in April. It looks very similar to that. However, I also got the colors of the, kind of like the Hubble palette. It's not quite the Hubble palette because I didn't use any sulfur 2 filters, but you can come up with different colors just depending on how you shade your red, green, and blue elements into your photo processing software. So with that in mind, I'm impressed with some of these colors. Now, M16, M17, and M20, and what's the other one? M8, all in the southern skies, coming up early in the morning now. M16 is rising around midnight. It doesn't clear my tree over here until about 2 o'clock in the morning, but I'm able to get it after 2 o'clock in the morning. And with Nina, it makes it really easy because I just set it and then I go to bed. I wake up in the morning, hopefully everything went well. One night I did have a cable snag, which didn't help to cause any. It ripped one of the cables right in half. Anyway, I got a thunderstorm moving in right now. It's right over there. And I think I better cover up this telescope right now to prevent the rain from coming on it. Anyway, thanks for watching, and remember, the heavens are filled with majestic wonders, all in a sky near you. And unless you need rain, I can use a little bit right now. Unless you need rain, clear skies, everyone.